840 feet of warship, built to carry over 2,000 Marines, aircraft, landing craft, a hospital, and a command center in one hull. USS Boxer belongs to the largest class of amphibious assault ship afloat, a floating base built to take Marines into battle. Then, in July 2019, a single drone in the Strait of Hormuz exposed cracks that no amount of firepower could fix. USS Boxer carries the official designation LHD-4, placing her in the WASP class, the largest amphibious assault ships ever built. At 844 feet long and 106 feet at the beam, she stretches nearly the length of 3 football fields and displaces over 40,500 tons fully loaded. These dimensions are not just numbers, they define a warship designed to serve as a floating assault base, not simply a transport. Boxer's hull is engineered to house over 2,000 Marines, dozens of aircraft, and landing craft for direct sea-to-shore operations. Every deck and compartment is calculated to support aviation, command, medical, and logistics functions in a single integrated platform. The Navy's investment in Boxer reached $340 million at the time of her construction, a figure that reflects the complexity and ambition of building a mobile airfield, hospital, and headquarters at sea. WASP-class ships like Boxer represent the upper limit of amphibious warfare capability, with the size and systems required to launch large-scale assaults or sustain humanitarian missions far from home ports. The scale of Boxer's design, her length, displacement, and cost makes clear why such a vessel is central to U.S. military strategy. She is built to deliver power, command, and support wherever Marines are needed, without relying on land bases or friendly harbors. Steel for Boxer's hull arrived at Ingalls Shipbuilding in Pascagoula on December 1, 1990. Within days, the shipyard's industrial cranes began shaping the first hull blocks. The official keel authentication took place on April 8, 1991, as workers joined the initial sections and affixed the keel plate, a ceremony that marked the true start of construction. Over the next 2 years, the shipyard assembled more than 12,800 tons of steel and 1,420 tons of aluminum, threading in 320,000 feet of insulated cable and laying over 260,000 feet of piping. Each step demanded tight coordination, hull blocks lifted by gantry cranes, decks welded together around the clock, and compartment after compartment outfitted to Navy specification. Mike Turner, Ingalls' senior welding foreman, later described the process. "You don't weld a ship this size. You build a city and seal it watertight." Boxer's hull slid down the launchways on August 13, 1993, entering the water for the first time. Afterward, the shipyard teams spent more than a year completing the internal systems, combat electronics, and living spaces. On September 30, 1994, Ingalls formally delivered the finished vessel to the Navy, certifying that all systems met operational standards. The final milestone came on February 11, 1995, when Boxer was commissioned at Naval Air Station North Island, ready to serve as a mobile base for Marines and a command platform for future missions. A ship like Boxer is built to deliver a fully equipped Marine Expeditionary Unit. That can mean up to 2,070 Marines, along with their vehicles, aircraft, and supplies, delivered directly into contested environments. Unlike traditional troop transports, Boxer functions as a floating assault base, able to launch operations without any reliance on shore facilities. The ship's mission is to support expeditionary warfare at sea and ashore, providing a mobile platform for command, aviation, logistics, and medical care, all within a single hull. This concept allows the Navy and Marine Corps to position combat power wherever it is needed, regardless of local infrastructure. Boxer embarks not just infantry, but a tailored force package, including armored vehicles, artillery, and aviation elements staged aboard and ready for rapid deployment. In practice, the ship can carry dozens of tactical vehicles, including amphibious assault vehicles and light armored reconnaissance units. Cargo holds and vehicle decks are designed for quick offload, supporting both combat landings and humanitarian missions. The embarked air wing and landing craft mix shift with each deployment, adapting to mission requirements and regional threats. For a major amphibious landing, Boxer can deliver Marines to shore using a combination of MV-22 Ospreys, CH-53E, heavy-lift helicopters, and landing craft air cushion vehicles operating from the well deck. During crisis response or disaster relief, the same spaces are reconfigured to move supplies, medical teams, and equipment ashore in hours, not days. Boxer's ability to sustain a Marine force at sea for weeks, launch them ashore, and provide continuous support without needing a nearby base defines her operational purpose. This expeditionary flexibility is what sets her apart from any simple troop carrier, turning the ship into a forward-deployed command and support hub wherever American interests require a presence. Boxer's architecture is built around a two highways concept, two massive decks, one stacked above the other, each engineered for a different kind of battle. The upper deck runs the length of the ship as a full-scale flight deck, a mobile airfield for helicopters, tilt rotors, and short takeoff jets. Directly below, the well deck forms a cavernous bay that can be flooded to launch landing craft and amphibious vehicles. This vertical layering lets the ship move Marines and their equipment from sea to air to shore without interruption, supporting simultaneous aviation and amphibious operations. Design engineers at Ingalls Shipbuilding faced a challenge: how to power such a complex multi-mission warship without the bulk and maintenance burden of older steam plants. Their answer was to fit Boxer with 4 General Electric LM2500 gas turbines, each delivering over 17,000 shaft horsepower. Together, these turbines generate nearly 70,000 shaft horsepower, enough to drive 2 massive controllable pitch propellers and sustain speeds above 20 knots, even at full combat load. The turbines are arranged in 2 engine rooms, feeding power through reduction gears and a fully automated control system. This setup gives the ship both the raw speed needed to keep pace with carrier strike groups and the electrical output required for flight operations, well deck machinery, and command and control systems. Stacked decks and gas turbine propulsion are not just technical choices, they are the backbone of Boxer's flexibility. The design allows for rapid reconfiguration, whether launching a wave of Ospreys and helicopters or flooding the well deck for landing craft. But this complexity also means more moving parts, more maintenance, and more points of strain. Senior design engineers, like those at Ingalls, have described the WASP class as a balancing act. Every gain in operational reach or speed adds new demands on engineering crews and shipyard teams. Boxer's 2 highways layout and turbine plant remain central to her ability to serve as a floating assault base, but they also create the trade-offs that shape her operational reality. The flight deck of USS Boxer operates as a non-stop launch pad, where tempo is measured in sorties and every minute counts. With the arrival of the F-35B Lightning II in November 2024, the ship's aviation reach expanded sharply. Deck crews now manage a mix of MV-22 Ospreys, CH-53E Super Stallions, and the new short takeoff and vertical landing jets, each demanding their own fueling, arming, and heat management routines. The flight deck itself was upgraded with a heat-resistant coating and new fueling stations to handle the F-35B's exhaust and rapid turnaround cycles. An aviation maintainer describes the rhythm as relentless. You are balancing Ospreys and F-35s, watching deck temperatures and cycling aircraft every half hour. There is no margin for error. During peak operations, Boxer logged over 20 flight cycles per day, with the deck serving as both runway and repair line. The result is a floating airfield that can project marine air power hundreds of miles from shore, setting the stage for the next phase, moving Marines and gear from sea to land. Boxer's well deck stretches 268 feet long and 78 feet wide, a space large enough to launch 4 LCACs or 2 LCU landing craft at once. Deck petty officers direct the choreography, signaling crews as the bay floods in under 15 minutes, and air cushion vehicles roar to life, ready to carry Marines and vehicles straight onto a hostile shore. The same lower deck houses maintenance shops and storage areas, supporting days of continuous operations without outside help. Just forward, the ship's medical officer oversees a 41-bed hospital with an operating room, intensive care unit, and dental clinic, prepared for both combat casualties and humanitarian emergencies. At the heart of Boxer's command and control, the Combat Information Center fuses radar, satellite, and drone feeds, giving commanders a real-time view of the battle space. Every system and specialist aboard is focused on one purpose: keeping Marines supplied, cared for, and in the fight, no matter how far from home. On July 23, 2019, as Boxer navigated the Strait of Hormuz, an unidentified drone closed to within 1,000 yards. The ship's electronic warfare operator tracked the approach, issuing repeated warnings. When the drone pressed on, Boxer's crew used electronic countermeasures and then fired from the bridge, shooting the craft down. The Pentagon called it a defensive action, and Iran denied losing any drone. Behind the headlines, Boxer's maintenance supervisor faced a different battle. A Government Accountability Office report revealed a growing backlog of critical repairs, including forced draft blower failures, compromising ventilation, and a rudder actuator problem that forced the ship to limp back to port in early 2024. These technical strains, documented by the Government Accountability Office, show the pressure on a ship that must remain ready for combat, aviation, and command duties at all times. Today, Boxer stands as a floating assault base, essential but never immune to strain. As global flashpoints demand rapid response, her unique mix of air, sea, and command power remains irreplaceable. Strategic readiness now depends as much on sustaining these platforms as on deploying them. The future tests both.